Well, my name's Derek Carter, aka Goozbach, and I'm a bit of a geek. Been doing this Linux thing since 97, 98. I installed Red Hat Linux 5.2, not Red Hat Enterprise Linux, Red Hat Linux 5.2. Nearly bricked my parents' computer, then installed Mandrake. Been doing Linux for quite a while now. I spend my days doing infrastructure-related tasks. I consider myself a infrastructure engineer. The more popular term nowadays is DevOps engineer, but DevOps is not a title. I can get into that afterwards if you want. DevOps is a methodology. DevOps is what you should have been doing all together and all the time anyhow, right? DevOps is what good ops people have been doing since the beginning of computing. I've been lucky enough to do Linux trainings for Fortune 500 companies, IBM, Red Hat, HP. I've done some consulting for government contracts, teaching, contracting, infrastructure-related stuff. Currently running a fairly advanced Kubernetes platform and dealing with the release management and DevOps tooling for that as well. So yeah, that's me and what I've been doing. Who here is running container-based OS in some form or another? By raise of hands. Or running containers. Containers in their infrastructure in any way, shape, or form. All right. Who here is or would consider themselves an operations person?
I'm a DevOps person.
More dev related? Somewhere in the middle? Yeah. All right. Who here would consider themselves to be a security person? All right. Vault, what is this thing? This is, it's a tool written by HashiCorp. It's kind of got the freemium model where you get 90% of the features for free and then you can pay for extra features with an enterprise license. It is open source, I believe, don't quote me on this, that it's MIT licensed. But it's essentially an API for securely storing secrets. It's an HTTP API that you can use to store and recover secrets. Well, that's kind of silly, Derek. Why would I want to do that? Well, you want to know what's going on with your secrets, right? You want to know, hey, did so-and-so access this secret? Or I only want these 4 people to know what this specific secret is. Or I want to know the last time that this secret was used. If you wrap that in an API, throw an audit engine on the back end, and you've got a fairly robust set of check marks that helps you deal with all sorts of compliance. Anyone here working in a compliant environment? HIPAA, PCI, others, right? You've got to worry about compliance. We just finished an audit, and our auditor came to us and said, what are you doing to protect your passwords? And I was like, well, we run HashiCorp Vault. And he went, oh, he's like, okay, well, we can skip over the next 3 paragraphs because it checks all those boxes, right? It's got an audit backend. He's like, is the audit backend enabled? Are you using tokens? And so on. It's like, he's like drilling down through, shared credential usage, the things that help you fail an audit. Vault helps you alleviate those. So it's a tool that enables your business to safely and securely use secrets. In order to talk about Vault and secrets, we need to talk a little bit about encryption. There's basically 2 types of encryption. We have symmetric encryption, which is where you use the same key to encrypt and decrypt the data, the plain text. If you ever used a Caesar cipher where you replace A with C, B, so you rot 13, it's a Caesar cipher, right? You replace one letter with another one. Not very secure, but the same key that you use to encrypt it, you use to decrypt it. Right? That's a symmetric encryption algorithm. A one-time pad is another symmetric encryption algorithm. Right? It looks like this. Plain text goes through a key, an encryption key, which in this case we're representing with a combination lock because everybody has the same combination. And on the other end, it's ciphertext. That's why that file's locked. To get back from the ciphertext to plain text, you push it back through the same key. It's symmetric. Asymmetric encryption, on the other hand, uses a very interesting feature of large prime numbers is that they're hard to factorialize and lets us encrypt something with one key and only decrypt it with its corresponding private key. So you use your public key, which you send out into the world. Someone wants to send you something secure. They encrypt it with your public key. And if you've got your private key secure, they can be sure that the only person who reads that ciphertext is you. Right? There's a problem with both of these. The biggest problem with symmetric encryption is you have to securely get the key from person A to person B. Right? The Army historically solved this by locking that in a briefcase, handcuffing that briefcase to a Marine, surrounding that Marine with other Marines, and then sending the whole lot to the other side. Right? Not all of us can do that. Symmetric encryption, which looks like this, we take the plain text here, we put it through the pub key, and that generates ciphertext. To get the ciphertext back, you put the ciphertext through the private key, and that gets you back the plain text. If you try to push that ciphertext back through the public key, you get crap. Right? You get butkus. How do you transfer the key? Well, you just publish it on your website. You put it on your business cards. You put it in flyers and drop it out of airplanes. It doesn't matter. It's public. You make sure that private half is super secure, though. The downside to asymmetric or private public key encryption is that you have to validate that the public key belongs to who they say it does. And this is where you get into the key validation problem. There's two ways of solving that. One of them is the CA architecture, which is everybody trusts a single entity. And I trust this entity, and he tells me that James is who he says he is. That's how the web mostly works, right? Everybody uses a TLS certs, and there's a handful of TLS signing authorities. A large handful, a six-fingered handful. And the other option is to use something called the PKI, Public Key Infrastructure, where I trust Doran, Doran trusts Steve, Steve trusts James, therefore I can send something securely to James. That's how that works. But that's not neither here nor there. We just need to know that there's two types of encryption. Vault uses both of them. There's a bunch of different features. The big three are secrets management, data encryption or encryption as a service, and access control. Who here has written an application that uses a database? All right, one of the things that an application that uses a database needs is a username and password to get to that database. You can hard code that into a config file, and then the second that someone compromises the server, you're out of luck. Or you can put a Vault client library for your application into your application and give it a token to Vault and say, hey Vault, what's the username and password for the database for the foo service? and Vault will come back and say, here's your username and password. Two ways of doing that. Key value stores, which would be this secrets management engine, or there is actually a database dynamic credentials feature for Vault. So your app reaches out and says, hey Vault, I need access to the foo database. Vault goes out to the database, creates your access, gives it back to you, and then that access has a TTL. Okay, you've got 10 minutes to do what you need to do in this database. And then I'm going to go pull the rug out from under you and lock that door. Pretty cool feature. You can do TLS certs. So if you are running a bunch of secure microservices and you want the encryption on the wire to be encrypted, you can use Vault as an internal CA, and as a new service spins up, it goes out and requests that its key gets signed by the Vault CA, and then everybody trusts the Vault CA and they can communicate securely. Whole bunch of other features. We'll get into some of them shortly. Let's first talk about how Vault secures the data that you give it. So Vault writes to a database of some sort. It can be a file on a file system, it can be Postgres, it can be MySQL, it can be etcd, it can be console. There's a whole bunch of data backends or storage backends. However, all of that data is encrypted at rest with something called the encryption key. It's a symmetric key. And that encryption key is then also encrypted in various different ways. There's a single password, a shared password, using Samir's secret sharing scheme, SSSS. Did you ever see that old episode of The Simpsons where they had that obelisk or that safe that took like 10 keys to open? And that's the idea behind Samir's secret key sharing. You get a quorum of keys together, and then you can unlock the master key, or you unlock the master key, and then that unlocks the encryption key. You're using AWS, GCP, Azure, or have another Vault server running somewhere else. You can store the master key password in one of those and get automatic unseals. So when your Vault server reboots, AWS goes, hey, this server is allowed to touch this thing using IAM rules, and it'll unlock it for you. This is what it looks like. The Vault server writes through the data encryption key to the Vault storage, whatever that Vault storage happens to be. This data encryption key, by default, is locked by the master encryption key. And the normal way you do things is with the Samir's secret sharing scheme. So what we have set up is you need X of Y key bearers or shard bearers to unlock the key. For example, if you have 5, quorum of 5 users would be 3. So this is all configurable as you set up your Vault system, right? So if we say I want 3 of 5 keys, it breaks the key up into 5 chunks, and then if any 3 of them get together, they can unlock the master password. So every time you reboot your Vault server with this scheme, 3 people have to get together, they have to log in and unlock that box. That makes sure that your secrets that are down here in the storage are as safe as they can be. How do you run Vault? It is a Go binary. The client and the server are the same binary. So you just download it from HashiCorp. I believe Fastly has like the CDN for this, but it's on GitHub, and you go to HashiCorp's download page and you download it. You can run that as a binary on Linux, Mac, Windows, I believe. Hey, why not? A Linux subsystem for Windows is pretty slick. You run the binary, or you can run it in a container. There is a HashiCorp published container based on Alpine which is just enough to run a Go binary and the Go binary. It also lets you have do the Vault client inside the same container, which makes a really nice, useful thing. You don't have to modify your system. You just do Docker run Vault, and it's running, which is kind of cool. Let's look at what that looks like. Helps if you do it with this. So I have the Vault server running on this box, and then I can just do Vault config. I've got the UI turned on, which is kind of cool. We're going to talk about this in a minute. Disable clustering. Yeah, I don't want to do clusters. You can do Vault clusters. So if you're running a secrets engine in your infrastructure, and it's very important that your infrastructure stay up, you probably want to be running Vault in a cluster, right? There is one caveat with running Vault in a cluster. Only a certain subset of the storage backends are cluster enabled. etcd, console, and one other. I forget what the other one is off the top of my head. So you have to be running one of those storage backends. I would suggest using etcd. It's the cleanest. Set up your TCP listener. This is where you would pass in the TLS cert if you were doing things in prod. It'd be really, really shitty if you set up this Vault server and turned TLS off, and then someone requested a secret and it went across the wire in plain text, right? So you need to make sure that if you're running this legitimately, you're running it with TLS certs, right? Set up the storage. And then another important little thing here, this I had to do because I'm running it as a non-privileged user on my Linux laptop. Vault needs to have IPC lock turn on, or mlock, which basically says that this memory can't go to swap. And that makes it much more secure to run, right? So that has to run as root to do that. So that I've just got it turned off here. You should not do this in production. But that's a very important little caveat I wanted to share with you. If you just tried to copy my config file and you ran it in production and someone compromised the box and was able to dig your master key or your encryption key out of your swap file, don't come running to me, right? You specify what you want for the storage. Like I said, lots and lots of storage options. You set up your listener options, and then you set up your seal. The seal is what this guy is. What are you using to encrypt the data encryption key? You're going to be using one of the cloud-based seal mechanisms, Google Cloud, AWS, Azure, they all have key management systems, or you're going to be using Semir secret sharing. Those are the two options for sealing. So that's something that you need to set up. If you don't set it up, it's going to assume you're wanting to use Semir's secret sharing scheme. Once you've configured it, once you've started it, the next thing you have to do is initialize it. And this is probably the most important step. If you don't do this securely, you've given away the keys to the kingdom. This is what sets up the data encryption key and the master key. By default, if you just do vault operator init and you give it the number of key shares and the key threshold, it spits them all out in plain text. So if I was the administrator of this box and I had 5 of you, I would run this command and then I would copy and paste each line and send it to you in an email.
Encrypted.
Oh, what was that?
Encrypted.
Encrypted email. You see the problem right here is all of these unsealed keys are are plain text right now, which means that I, as the operator, know how to get quorum and am therefore suspect if something were to go wrong with secrets disappearing. For example, someone started decrypting a bunch of social security numbers and sending them off. There is a better way. Oh, before we come back, we'll come back to this root token thing in just a minute. So that's another thing that happens during init. A more secure way is using Vault's built-in PGP options. When you do an initialization, you can specify, I want 5 keys, and here's the 5 PGP keys to encrypt it with. Oh, also, here's the key to encrypt the root token with. And that lets you securely and safely transfer that initialization step. So if you're going to do this, do it using PGP. This will protect you, number one, from people reading passwords sent in clear text in the email. Number two, it will protect you as the operator from knowing how to get to quorum. Right? Those are the two things that PGP mode protects you from. The downside to PGP mode is that the flags to use it aren't very human friendly. I screwed up enough times that I actually wrote a little script, a wrapper script called Vault Helper. It's on my GitLab page. It's a bash script that uses just a couple of variables that you have to set, and then you run the command, and then what you get out of it is a tarball full of everybody's encrypted shards, which is kind of cool. And then you just take that tarball over to your laptop, and you send them off to everybody who's a key bearer, right? A shard bearer. Very, very cool tool. A little bit outside the scope of this presentation. All right, let's get back to that root token. This is keys to the kingdom once your vault system is unsealed. So that's actually something I need to write down. One moment. I don't have a slide on unsealing. So I should add that. But unsealing is the number of you that reaches the threshold come together and you pass your unseal key to Vault, and it will unseal once it's got quorum. So that's what an unseal is. Once Vault is unsealed, you need to log into Vault to do anything else. It's essentially a file system once you get into it, but you log in for the first time with the root token that was generated during the init step. This is keys to the kingdom. This is a token that can do anything. It's also the only token that does not expire. Therefore, you should probably immediately create other credentials with which to log into Vault. There's a couple different ways of doing that. We'll get to that in a second. Again, best practice is to take your Vault root token, and the only thing it does is create another authentication mechanism, be it turn on LDAP, turn on Okta, turn on just another token that only one person has the access to. Usernames and passwords is another option for logging in. We'll get into the role-based access control in just a minute. But yeah, the ideal option is that you create your alternative login and then you delete the root token. But Derek, how can I fix something or reset the root token if somebody needs something that they don't have access for. If you have quorum, you can create a new root token. So you get 3 of the 5 shard bearers together, and you can create quorum if you need to create a new root token.
And when you delete the root token, is it deleted in Vault as well as the token that was given to you?
That token that was given to you during the init is gone. So the question was, when you delete that root token, is it gone? And it's gone.
Well, so do you delete it in Vault?
Yes.
Okay.
So so how do you do it? It's you log in with the root token. You create your alternative login mechanism that has admin privileges. You log out from the root token, log into the alternative admin mechanism, and then issue the delete token, blah, 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 and that'll delete the root token in Vault. Yep.
So you're saying that is what, because root has so much power, you should create an admin user, log in, and then remove the root token so that way
Immediately.
it doesn't exist anywhere.
Doesn't exist anywhere. No one has that full power anymore. The other benefit is when you create that admin login, you should have 1 admin login per admin, right?
Don't share it.
So that gets rid of the shared credentials. The reason you do that, whatever mechanism you use, LDAP or token-based or username and password, only 1 person should have access to that. And the reason for that is that every action in Vault is audited.
Right.
So if something happens with admin access, you can go back to the audit log that hopefully you're shipping off to somewhere secure, and you can see who did what.
Are shard bearers admins, or can they be non-admins?
Not necessarily. Shard bearers, the only thing a shard bearer can do by the power of obtaining and holding a shard is unseal Vault.
Okay.
That is the only thing that shard can do.
And then they have to have a different.
And then once they've unsealed it, they can log in with their personal creds.
Okay.
So a shard bearer is not necessarily an admin.
Okay.
Most of the time, all of your admins are shard bearers,
Right.
but a shard bearer is not necessarily an admin.
Gotcha.
Yep.
So when do you need a shard bearer?
There are
Every time you start it?
2 times you need a shard bearer. Anytime you restart Vault and need to unseal it, multiply that by the number of members in your cluster. Each cluster needs to have it unsealed. That makes sense, right?
Each node in the cluster.
Each node in the cluster needs to have a copy of the encryption key in its memory, and the only way of getting the encryption key into its memory is unencrypting it. So each node in the cluster has to be unsealed separately. So that's reason number 1. And then reason number 2 is to generate quorum to create a new root token. Those are the only two times that a shard bearer is needed. Now, waking up at 4 in the morning because your Vault cluster kicked itself in the teeth really, really sucks. That's why you commonly, if you're using AWS, if you're using Google Cloud, if you're using Azure, if you're using one of those 3, you probably want auto unseal. So there's 1 shard bearer, and it's the AWS key management system. However, what happens if AWS goes Tango uniform? Well,
You got bigger problems.
there's something called a recovery key. So they make a backup master key that's encrypted with Samir secret sharing. So the shard bearers still come together for root token generation, and if you need to move away from the auto unseal key to a Samir key, you can migrate your seal status from one to the other. So that's how you have that the recovery option. All right, authentication mechanisms. There's a whole slew of them. Usernames and passwords. You statically write these and create them. You can tie it to LDAP. You need a bind DN and a bind DN password to do so. You can do TLS client cert auth, which is kind of cool. So if you've got a CA that's signing a client cert and a client says, hey, give me access via this TLS cert, it goes and checks to see that it's signed properly and just grants access. This is how services authenticate with Vault, right? Applications authenticate with Vault normally either via an application token or with a TLS client cert. Kubernetes is an authentication mechanism. So you can say, hey, Kubernetes service account has this amount of access. And then the service account, the app goes in and it pulls a file off of Kubernetes virtual file system and can send that token off to Vault to authenticate. I did not add tokens. So token auth, there's root tokens and other tokens. So there's not just root tokens. You can create a token-based auth that has limited amount of access. You can also use your cloud provider's identity management solution. AWS, IAM can be an authentication mechanism for Vault. We're using LDAP at the office, and we're moving to Okta, which is fantastic because I can get rid of all the funky config in my LDAP server, and Okta's just, if you're in this group, you have this role, which is fantastic. Roles and policies. This is something that you need to worry about when you're starting to create your Vault layout. So Vault is basically just a file system, and you can grant access to a subset of the file system paths based on policies. So I have an application named foo and an application named bar. I want the application foo to have access to all of the secrets under /secret/foo. I want the application bar to have access to all the secrets under /secret/bar. So I create a policy called foo access that grants access to everything under that path, a bar policy that goes under everything under the bar path. Then I tie that policy to a role. So I create a foo users role, and then I bind tokens or users or groups to the role. Does that make sense? Policy, role, user or token, right? A role can be a member of multiple policies. So there's an admin's policy at the office that has, or it's called Vault Power Users, which basically says the Vault Power Users role has access via all of the sub-application admin policies. So the Vault Power Users can change secrets for any app in my infrastructure, but they can't change Vault config, right? The Vault Admin's policy, on the other hand, is essentially a root policy that can let them change any path on the Vault file system. I need to put some examples of this in. I don't have any in the app, but I can show you one that I used for a different nope, didn't want that. Find my actual policies here. So here's what a policy looks like. You give a path in Vault. Example CA is a path that I set up at one point, right? And then I give it list and read access. So this is a policy for, you can list and read from anything under example CA. In addition, under sign, the domain / and whatever the item was, this is a template, right? But this would be replaced with whatever. I can list, create, update, read, or delete. So I can sign assert under example CA with this policy. And I can be really, really granular, right? I can write to this path but not read from it. So you can set up Vault so that someone can change a password but not know what the previous password was. Right? Like /secret/foo, I have write access to that. Okay. I can write to it, but I can't read from it.
So in this, you have example CA and then 2 more paths that are under example CA.
Uh-huh.
Would it inherit the above list and read? Like, do you need to
The
include
most
both ones?
explicit match wins.
Okay. It
So,
won't inherit the above one. It will just.
well, it will.
Include list and read.
On this, yeah.
I've got list and read here.
Yeah, if those weren't included, would you still be able to?
I wouldn't be able to list and read everything under signed domain foo.
You wouldn't?
Would not.
Okay,
The most explicit match wins.
okay.
So if I'm trying to read example CA signed domain foo, and I didn't have list and read on this, I wouldn't be able to list and read it, even though I've got it up here.
Okay.
There's no inheritance.
Okay, that's what I was curious about.
Okay, that's not entirely true. The most explicit match wins, and if something at a lower path is not explicitly called up, it goes up the tree to the most explicit match. So if I didn't have these 2 entries, anything and everything under example CA I would have list and write to, or list and read, right? So I don't have to explicitly call out example CA foo bar baz
Right.
because of this star right here, right?
Mm-hmm.
So the most explicit match wins.
Okay.
The star is what makes this anything under that path.
Yeah. Understood.
All right. So that was that. Vault roles, access policies. Most of your time in your initial setup is going to be configuring your policies. It's the most important to get right. Pardon me. If you don't get your policies right, secrets leak, right? The place you're going to spend the next amount of your time is configuring all the various backends. Strike that, reverse it. You're going to configure all the various backends, and that will define the paths that you put into your policies, right? You need to be able to see /foo before you can grant a policy to /foo, because /foo has to be mounted in a certain backend, right? One of the cool features with the 1.0 release of Vault is that a previously paid-only feature, the Vault UI, became part of the open source release. And you can do almost everything that you can do via the API with the UI. There are a couple of things you can't do. Mostly backends that don't support the UI yet. Of certain types of backends. You still have to use the API to do those things. What does the UI look like? Well, let's look. We're going to sign in with a token. That's not what I wanted. My root token is this.
You didn't delete it?
Well, no. Do as I say, not as I do. So I sign in with the token. Boop. Never use that password. Welcome to Vault. Did you see that notice before it disappeared? Basically said, hey, this is a root token. You're doing something very dumb. Like, if you break it, you get to keep both pieces. So there's one secret engine that is always mounted, and it's called the cubbyhole. Think of it as your own personal Fort Knox. And it's tied to whatever token you have. So the cubbyhole is your own private namespace. You can store stuff in there, and then the second your token expires, poof, it's gone. I have mounted another secret engine for a transit key. We'll get into what a transit key is in just a minute. I want to turn on a new engine. So I'm going to turn on a key value engine. I'm going to click Next. I'm going to give it the path, secret, and I'm going to use version 2. There's 2 versions of the key value. The first one is basically just return the key value. The second one lets you actually have history. So V2 lets you go like, this secret on February 21st was this, but now it's this. I can set up a bunch of different options, but we're not going to worry about it. So you can actually turn on, like, if someone uses this key, you can exclude it from audit. Like, you don't even want anyone to know that this is being used. We're going to enable the engine. We successfully mounted the secrets engine at /secrets. So now we're going to create a secret. And this secret's going to be foo slash, let's see, what's an API that y'all use occasionally? Twilio, right? Twilio? Is that the right one?
I use Botto.
What's that?
I use Botto.
Botto?
Slack.
Slack. There we go. That makes more sense. Foo slash Slack. So we have the foo app, and maximum number of versions. For some reason, oh, my scrolling is upside down. The key is Slack API key, and the value is that. You can click Save, and there you have it. This is the Slack API token that the foo app uses to send messages into Slack, right? So what we do on the foo app side is we give it a login mechanism to Vault, and we tell it where the secret is. /secret/foo/Slack. And then the app goes out, requests what that secret is, stores it as an environment variable or whatever it does, or a global variable in your app language, and then it uses that to connect out to Slack. And every time that Vault requests that, it goes into the audit log. Kind of cool, huh? You can get it in JSON format. You can look at the version history. It doesn't show it to you by default, which is kind of nice. Or you can just have it copied to your clipboard. And then you use policies to grant access to /foo/Slack, right? So that's the secrets back end. All right. Any questions thus far? No? All right, we saw the key value. This is where you store stuff that your application needs. Database passwords, API keys, private keys for SFTP transfers, etc. Right? Once you've done that and your app's are used to going out to Vault and asking for a database username and password, you can graduate to using the database dynamic secrets backend. What you do with this, and I don't have a demo set up, you give this backend username and password for your database engine that has create database and create roles permissions. And then an application reaches out to Vault and says, hey Vault, give me database creds. Vault reaches out to the database, creates the cred, and returns them to the application. Normally those creds have a timeout. 1 hour, 24 hours, 30 days. We have a 30-day dynamic database passwords for our applications. We kill all of our Kubernetes pods at 28 days. So Kubernetes pod gets to 28 days, it automatically dies, it refreshes the app. If the app hasn't already been updated in that 28, it's really rare for any of our apps to last longer than 28 days anyhow. And then it gets a new cred from the database to do access to what it needs to. If someone needs temporary access to the database to fix a problem, we grant them 4-hour database creds through a little admin interface that we wrote. And it has to get approval from their manager, right? So you go, hey, I need admin access to the production social security number database. Oh, well, what's the business use for this? Well, customer foo is having problems because something's funky with their account. All right, well, go into that room and fix it. You have 2 hours before your creds expire. Right? And because everything has a token, including this dynamic credential, when he's done in an hour and a half, we can go revoke that token. Vault goes out to the database and says, okay, that credential's gone. So even if the person tried to connect directly to the database again, it's not there anymore. Transit keys. Who here is secure, is storing in their databases PII or PCI data? Anybody? All right. What's the rule? If you're storing PII or PCI, okay, that's the ideal world. If you can get away with not doing it, don't do it. Send the transaction off to Stripe, right? Don't store credit cards yourself. But if you have to, because that's part of your business model, compliance requires that the data be encrypted in flight. Compliance requires that the data be encrypted at rest. If I get the social security number from one of my users, the only time that can be unencrypted is never, right? TLS on my front end to my app's back end, the first thing I do with it is I encrypt it with a transit key. A transit key is a symmetric key. It's encryption as a service. So I say, 555, or let's see, 555-55-5555 as my social security number. I send that off to Vault and say, hey, encrypt this for me. The Vault policy determines whether or not I can encrypt something. It gives me back ciphertext. Then if I need to use that social security number, I take the ciphertext and I go out and say, hey, Vault, decrypt this for me. If the Vault policy allows me, it sends me back the unencrypted social security number. So what I do in my app is I reach out to Vault when I get a new string that needs to be encrypted. I say, encrypt this for me, I get that back, and that's what I store in the database, is the encrypted value. The cool thing about transit keys is that they're rotatable. So if I have, for whatever reason, a compliance requirement that my encryption keys be rotated once a quarter or once a year, I make a single call to Vault, And every new piece of data that goes through that transit key is encrypted with a different key. But guess what? I can still get the old data back up until a certain point, right? I can get rid of old keys once I'm sure that all the data has been migrated to the new key.
So when an old key comes in and says, hey, decrypt this for me, it says, okay, and then it updates it?
It does not update it in the database.
Okay.
At least I don't think it does. It's what you do is, or actually no, your app goes out to the database, gets a v1 stringed secret, sends it to Vault and says, decrypt this for me. Vault decrypts it, sends you back the clear text. It's on you as the app developer to go, oh, that was a v1, re-encrypt this for me, and then store the re-encrypted version. It's on you on the app developer.
This Vault doesn't actually store
The plain text.
thing at all, either.
Vault doesn't store anything. Vault,
It just knows the encryption key.
it knows the encryption key. So there's no storage in Vault of the data that you're sending through a transit key. It's just the key.
So the app has to be aware that the version changed.
Not exactly.
So does Vault come
If-
back and says, oh, here's your clear text. By the way, we're at a different...
This will make more sense in just a minute. If you've
Okay.
got this question still in 5 minutes, then ask it again.
Okay.
Yep. So actually, let's look at this. I've got a little Ruby app that I created called Goozes, and the app. It's a Ruby on Rails app, and I'm not super familiar with this, so it'll take me a second to remember where it is. Okay, so here is the view in my Ruby on Rails app for this web page. I create a table, give it a header of a goose name, goose value, and goose decrypted. And then for each of the gooses array, give me the goose name, goose value, decrypted value, and then a link to each of those methods that let me edit, create, etc. Right? So that's the view. I need to look at the controller now. If I remember right. So there's the controller, def show, def index, def create. Hash put, nope, that's, okay, so that's not it. Maybe it's in the Goose controller, nope. Is it in the application? I don't know. I'm not a Ruby developer, if you can't tell. Models, views, controllers. There you go. That's what I was looking for. Looking for the model. So this is the logic here. I'm going to stand up now, Doran. Here's your chance to get me. This is the Vault is the Ruby Vault library. So Ruby has a Vault library. And I get the secret. This is my crypted value. When I write my plain text to transit encrypt gooses. So I send my secret value to that, and my plain text to that, and I also base 64 encode it. So I have to base 64 encode it prior to sending it to Vault. I write it to this path, and I get back ciphertext. That's what I put into my active record in Ruby that ends up in the database.
Why do you need to base 64 encode it? Does it only accept?
It's to protect from special characters. It's just good data sanitation practice. I'm not sure You know what? I think Vault actually requires it to be base 64 encoded, but I'm not 100% sure on that. But it's a good practice to get into regardless, because it gets rid of special characters, it gets rid of injection attacks, it gets rid of all of that jazz. You're just storing text.
Does base 64, does its length changes the secrets change? Okay.
Base 64 is an encoding scheme, it's not encryption. Or it's not hashing either. Yeah.
Okay.
So I get the encoded value, and that's my ciphertext that I just got back from Vault. And then the decrypted value, I write the ciphertext to transit decrypt gooses, and I get back the plain text. So that is the model, right? The application record for that object, right? And that's what gives me this. I created a new goose object, active record object in Ruby. Key, value, but before I stored it in the database, I piped it through Vault, and this is what it looks like in the database. Vault : the version number of the encryption, and then the base 64 string of the ciphertext. So if I make a new one, and I give it a name of plug is awesome, and I go back, this value is only getting decrypted by the app. It's never stored in plain text in the database. It's getting stored in the database like this. If I rotate my key, let's do that real quick. Takes a second. Maybe. Shouldn't have taken that long. There we go. Took a second to log in. It may be that it's been running for a while in the memories, because this is a simple Docker container. Come on. There we go. So what I did is I wrote to transit/keys/gooses rotate. And if I go back to my little app and I make a new one with the name of after rotate and the value of something. Actually, let's make that not garbage so that we can see that it comes back as ciphertext. I create it, and now you can see that it's a Vault v2, right? So if I want my data to automatically get bumped to the latest version of Vault, my application needs to know how to query Vault to see what the latest version of the key is, and it needs to know when it gets a value that was created with an old key, and it needs to send it back through the encrypt method with the new key, and then store the new value in the database. It's on the app to do that. Right?
So are those keys essentially, I mean, the V1, V2, do they represent essentially global keys?
This is per transit key. So you can mount the transit backend multiple times in Vault under different names.
But that is per
mounted transit key. So Vault V1 is the V1 of the goose's transit key, right? At work, we have transit keys for address, date of birth, and social security number. You can't unencrypt a social security number with a date of birth key, and they can be rotated independently. And this gives us benefits of we have a job that wants to run to send birthday cards to our customers. This is a completely fabricated example. But if we wanted to run a job that sent birthday cards to all of our customers, we would grant access to the birthday card generation job to just the birthday decryption key. And then they wouldn't be able to somehow get access to the social security numbers in the database. Right? They would only be able to get access to the unencrypted birthdays. All right, so that's the transit key. Coming up on the end here, vault architecture. What should your vault architecture look like? Anyone here running Kubernetes? If you're running Kubernetes, do not make the mistake we made, which was to run Vault inside of our Kubernetes cluster. Run Vault as an isolated surface. Trust me on this. You do not want your Vault infrastructure bringing down your production infrastructure because your production infrastructure went down because your Vault infrastructure was on top of it. Right? Run it separately. Run it isolated. If you're running in AWS, run it in a separate VPC. Right? Like run it as separate as you can get it. The only access to Vault should be via the HTTP API. You don't need to SSH into it. You don't need to, like the admins need to, but the people interacting with Vault as a service, run it as a service. Your apps and your users that are connecting to Vault. Put it behind an ELB, right? That's the architecture you should run it. Trust me, you'll save yourself headache after headache after headache. Run it as a cluster, because if one goes down, you want to still be able to get access to your secrets. That being said, when you run it as a cluster, spread it out as robustly as you can. Don't run 3 nodes in US West 1A, right? Don't run anything in US West 1, period. It's only got 2 availability zones. That has bit us in the ass. We had the availability zone that had the 2 nodes in it go down. Well, when you lose 2 out of 3 nodes, you lose quorum. When you lose quorum, you're done, right? Backups, 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 backups. How you do a backup kind of depends on what you're using as your storage backend. If you're using etcd, doing a backup is as simple as etcd, take a snapshot right now. Guess what? It's encrypted in etcd. So you can take that, toss it into S3, and you've got an encrypted backup. As a matter of fact, if you mount an S3 bucket into a file system using something like Fuse, you can just set up a cron job that takes a snapshot to that file system location every 15 minutes, every hour, every whatever your threshold is for data loss. And it automatically ends up in S3 safe and sound, right? So back it up. Test your restores.
You test your backups. There's no such thing.
There's no such thing as a backup. There's only restores. If you haven't restored, you haven't backed up.
I see.
There is no such thing as a backup. Test your restore. One caveat with this. If you rotate your master key, you need to keep the shards from history. Does that make sense? So one of the things you can do is you can rotate your master key and give all the shard bearers a new master shard. You need to make sure that if you have to restore from backup, you can still unseal from that backup. So keep all of your unseal shards in perpetuity unless they have been compromised. If they've been compromised, rotate and make a new backup and verify that all your old backups are gone. Right? But if you're going to do backups, keep at least the last 2 master rotations of your shards around. So if you have to restore from an older backup that has a different master key, you can. That's an important caveat there. All right, are there any questions? Comments? Yes.
So you have an application that needs a secret,
Uh-huh.
and it has a token. Where does that token go? How is that? I mean, because if the token is treated like a password, then you can't stick it in the Git repo with your app. So how does the app...
How do you bootstrap access to Vault is what you're asking.
Okay.
More or less, right? Like I have a secret token and that's how the app communicates with Vault. Where do I put that token?
Right.
The bootstrapping problem is probably one of the stickiest problems with this. There's a couple of ways you can do this. If you're running Kubernetes, you can run a service account and use the service account token and Kubernetes auth to bootstrap this whole thing.
So you would have to stick that token manually in Kubernetes, but then it handles everything after that.
So you do it once, and then as the app spins up, the app looks in this specially mounted folder in its container,
Right.
and it says, okay, it's like var run Kubernetes token, blah, 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 blah. Pulls that out of the file, it's in JSON format, parses it, takes that token, speaks to Vault, and then works.
Okay.
On the back end, Kubernetes has set that token up through the service account communicating with Vault. If it's a non-Kubernetes app, you've got to bootstrap the secret somehow. Commonly, I'd seen people use it just a Vault environment file, which is a JSON format that's owned by root with 0600 permissions, so root read-only or whatever, or app user read-only, which means that there's a token floating around on a file system somewhere, which kind of sucks. You can do TLS cert-based auth, client cert auth.
But the cert's a secret then.
But the cert's a secret, so how do you unlock the cert? Java key store. Well, then you've got the Java key store password. There's going to be a bootstrapping issue.
Okay.
Follow the best practices in your application language in your environment for securely bootstrapping a secret.
Okay.
The plus side is that it's an access token. It is not your secret. If it were to become compromised, rotate it. All the secrets are safe. And the old token doesn't work anymore. The other thing that's nice is that tokens can be created with TTLs.
Right.
So you have 60 seconds to log in and get your database password. Your database password is valid for 10 hours, but the token to get it is valid for 10 seconds or 60 seconds. So that's another way of securing that. Is the access token has a short TTL. The secret itself, the dynamic secret itself, has a longer TTL.
Okay.
What other questions do you have? You guys see running a service like this in your infrastructures? Yeah. Well, if you need help, Derek at goozbach.com. We can talk. I've spun it up multiple times. I'm running it in Kubernetes. I ran it the wrong way in Kubernetes, and I feel like now we're running it the right way in Kubernetes. We're working on making it better. I run it isolated. I've run it in a mobile classroom, which is something I need to talk with you about, is coming and do a demo of my mobile classroom in a couple of months or something. Really a powerful tool. This is just a scratch of the surface. You can get into audit. You can get into all sorts of other fantastic things with Vault. Any other questions, comments, concerns? Yes?
How do we see the audit trails?
You turn on audit by writing to a file system saying, hey, turn on the audit backend, and here's its configuration. So you do Vault write like you do any other configuration in Vault. The backends are file, syslog, and something else. I don't remember off the top of my head. But then it's just off, and then you look at it on this remote syslog server, or you look at it on the file system, and you then shift the file system off to somewhere else. You can enable multiple audit backends as well, which is probably a good idea. So
You could send all the connections to just a syslog server.
you can
Just grabs all the logs.
grabs all the logs. Like you say, hey, send it to this syslog server. Note that it's never going to print a secret.
Good.
It's never going to print a secret. Vault is smarter than that. What it does do is it uses HMAC to hash the secrets as it sends it along in an audit. So I need to know when this password last got accessed. You HMAC that the same way, and you search in the audit logs for that string. And then you see secret gerba gerba happened at 12:15 on February 2nd, right? By this token. And then you look at that token up, oh, that token was generated by user John, right? So all of that happens in the audit logs.
So HMAC is
I forget what it stands for, but it's a hashing algorithm.
You can't reverse it.
Yeah, you can't reverse it, but it's hash message authentication something or other. Yeah, it's not important. It's a hashing algorithm. Yeah, code, whatever. But to your concern behind the concern, I normally set up, especially in compliance environments, I set up file-based audit to the server itself, and then I use something like Logstash or Scalar or whatever, or Splunk or whatever they're using for their log aggregation stuff to pull those files up. And then I also do our syslog. It's duplicating the audit logs, but that gives you a little peace of mind that it hasn't been manipulated in flight. So that's one of the algorithms or architectures that I do. Well, if there are no further questions, I'd like to thank some people. I want to thank Johnny T, one of my coworkers. He helped me write. Did we run out of space?
No. No, recording it in your display.
Ah. I knew I was forgetting something. Very cool presentation hack. Created a second user on your laptop called presentation that isn't logged into any of your IMs or anything. And then always remember to disable the screensaver on that account. That's what I forgot to do. So Johnny T, one of my coworkers, him and I have kind of spearheaded this Vault thing. I want to give him a shout out for helping me write the Ruby app because I am not a developer. Many thanks to Nav, which is my current employer, which has kind of pushed this upon me. We need to make sure that we're secure. We're hiring, by the way. And thanks to all of you for attending.